Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is differing values. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given a binary string s of length n and an additional parameter k. You are wondering whether it is possible to rearrange the characters in s in such a manner that it follows the following condition. S of I should not be equal to s of I plus k for all the values of I going from 1 to n minus k. If it is possible, we will print yes, otherwise we will print no. We have the string s whose length is equal to n, and since this is binary, it will only contain the characters 0 and 1. Now, we are also given a value called k. So the elements at I should not be equal to the element I plus k, and this will hold for all the values of I that is greater than equal to 1 and less than equal to n minus 1. We have to find out whether we can rearrange our string s in such a way that this condition is followed. We will print yes if that is the case, otherwise we will print no. So for the input format, we have t test cases, and for each test case, we have two lines. The first line will contain two space integers n and k, and the second line will have the string s itself. For the output, we simply have to print yes or no. As for the constraints, number of test cases will go from 1 to 100. Value of k will be less than n, and both of them will be greater than equal to 1 and less than equal to 100. And as we know, since s is a binary string, it will only contain the characters 0 and 1. Let's see some sample inputs. So for the first sample input, the string length given to us is 4 and the value of k is equal to 1. So in this case, our s is equal to 1, 0, 1, 0. So if we take the indices from 1, it will be something like this. Now we need to make sure that our s of I is not equal to s of I plus k. So in this case, our k is 1. So going for the first index, s of 1 should not be equal to s of 2. That is correct. 1 is not equal to 0. Similarly, as we move ahead, s of 2 should not be equal to s of 3. And yes, that is correct. And finally, s of 3 should not be equal to s of 4. That is also correct. Therefore, the answer that we have here is yes. Let's see how we can approach the solution. So we have our string s of length n, then we have our index I here, and we have other parameter k here. What we're trying to do is, we are trying to make sure that our element at s of I, the ith index, is not equal to k plus I. So in this case, if we consider our, let's say 0th index or first index, and this is k, then this will be our k plus I, or k plus 1 in this case. We are talking that this should not be equal to this. So in this case, let's fix this character. If our s of I is 1, now this makes sure that our s of k plus I has to be 0. It cannot be 1. In the similar manner, this is also of length k, right? So for the next segment of k, what will be the value of this 2k plus I? Since this has been fixed to 1, it has to be 0. And since this is 0, this has to be 1. And this chain will keep on going on until we go over n. Now, if this chain has a length of even, if the length is even, then we will use equal number of zeros and we'll use equal number of ones, right? The count will be same. But in case that it is odd, we will have obviously zeros and ones, but we'll have extra. This extra can either be R1 or it can be 0. We'll come to this later. For now, let's see the chain. When we start from I, the chain is I, then k plus I, then 2k plus I, 3k plus I, so on and so forth, right? It covers our chain. What about the next element? The I plus 1. If you talk about I plus 1, if we decide it to be something, whether it be 0 or 1, the value of k plus I plus 1 will again be decided. If we decide it to be 0, the next value has to be 1. If we decide it to be 1, the next value has to be 0. So on so actually we only need to calculate or decide on the values of elements from the starting values of k. So if we take the index from 1, we only are worried about what values to pick from 1 to k, because after that these values have to be predetermined as per the condition, that is s of I must not be equal to s of k plus I. What we are going to do is, from the index that is 0 till k, we are going to go over each index and find the length of the chain. If the length of the chain is even, we know that the count of zeros and count of ones that we are going to use are going to be equal. If the chain length is odd, we need an extra 1 or 0. Now imagine a scenario where there are no odd length chains. In that case, it's very simple. Our count of zeros has to be equal to count of 1. Easy. So now we solve for odd. What happens? Let's say if we have some x amount of odd chains. Now among these x amount of odd chains, some r chains we can use 0, and rest of the x minus r we can use 1, because we don't have infinite number of zeros and ones. So we have to find the optimal value, or at least one optimal value of r that simply works. Now let's say we have found a value of r. What are the conditions that it must satisfy? First is that r must be equal, less than or equal to 0. That is, sorry, count of zeros. Why? Because this is obvious. These are the spare ones that we are using for our odd chains. We still need them for our even chains. So lot more zeros will be required. So it is good for us if the few ones that we are handing out to odd chains must be less than or equal to count of zeros. What next? The remaining that we have are going for ones. So that also has to be less than or equal to count of ones. Now, after we have handed out the extra ones and zeros to our odd chains, what about rest of the characters? They must be equal. That is, the remaining zero that we have and the remaining ones that we have must be equal. That is, C0 minus R, these are the remaining zeros that we have with us, must be equal to C1 and the ones that we used up to give odd length chains. This must be equal, because if you see, for even length chains we need equal number of zeros and ones, and since we have handed out the extra ones and zeros, these odd chains also require equal number of zeros and ones. So what we'll do is, first we'll find the total count of zeros and ones in our string, then we'll find how many odd chains do we have. Once we get that, that is x number of odd chains if we have, we'll go over 0 to x, we'll call it r, and we'll see if we can hand out r number of zeros to the odd chains and whether we will satisfy this condition. That is, after handing out r number of zeros, we'll hand out x minus r ones, and after giving all this, we must have equal count of zeros and ones. If you find such a r, our answer would be yes, otherwise our answer would be no. And with this, we get our solution that satisfies the condition in our question. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. We take the input of nk and our string s. We find the total count of zeros and ones. After that, we go over the indices from 0 to k, and we find out what is the chain length, that is, of character I, then k plus I, then 2k plus I, and so on and so forth until we reach the barrier of length n. We count the chains that have odd counts, because if it has even counts, we simply have to give equal zeros and equal ones. But if it is odd, we have to hand out extra ones or zeros, as we have seen in the approach. Once we get the total count of odd, we'll see how many of them can be zeros and rest can be 1. So for this, we initialize the r variable in our loop that goes from 0 to our odd count. We check if we give r zeros, what will happen? Then r must be less than equal to count of zeros. The rest of them must be less than equal to count of ones. And after removing them, what zeros and ones that we have left with must be equal. If you find such a solution, our answer is yes. But if after going all the cases, we don't find any such scenario, our answer would be no. And as we can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Similar to the C++ solution, for each test case we call the function solve, take the input of n, k, and our string s. we have count functions so that we can use them to find total count of zeros and 1. Then, going over the indices from 0 to k, we start our chain at the index I and we go over at each k length to find out what is the size of our chain. If it's odd, we increment that variable by 1. Then we find out how many of these odd chains we can give additional 0 and the rest of them we have to give additional 1s. After giving them, if we have equal count of zeros and ones, our answer is yes. Otherwise, if we don't find such a scenario, our answer would be no. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement this in both C++ and Python. Have a very good day, and I'll see you in the next video.